look like the controls are inverted from what we use in the United States. Anyway, now we come to tkinter. Some folks wonder how to pronounce this framework. Is it tkinter? I call it tkinter, and I think that's pretty much the standard way to refer to this toolkit, and it makes sense when you understand the origin of this word. tkinter means TK interface, and TK is yet another graphical user interface library that's a part of the TCL scripting language. TCL stands for Tool Command Language. It's a really quite a nifty scripting language. It's also called TCL. You know, we've come full circle with some pretty corny pronunciations and usages. When you refer to TCL and TK together, oftentimes you'll see this referred to or hear it referred to as tickle talk. Okay, I thought I had a corny sense of humor. As previously stated, tkinter does ship with CPython, the official python.org distributions of Python 3.x. In fact, the idle IDE that we've been using all along in this course is itself a TK application. Now that can sometimes cause development problems. That is, if we're using idle to test TK applications, hopefully it makes sense that there might be some conflict of interest going on in terms of spawning a sub-process. You have idle as one TK process, and then your application as a sub-process. If your TK application crashes, that may have an undue effect on idle. However, in my testing with Python 3.1.1, I've seen little to no problems along those lines. We're also going to look at some alternative IDEs in Python in a couple nuggets from now. And finally, frankly, some jock programmers don't even use an IDE. They just simply use text editors and the command prompt to test their application. So you can go that way too. As a point of review, remember tkinter and GUI apps in general are event-driven, so it requires a little bit different way of thinking from just a straight procedural approach or from object orientation. Now, the code behind tkinter is fully object-oriented. So if you haven't been watching these nuggets in series and you haven't yet watched the nugget on OOP, I would recommend that you go back and do that. So an event-driven application, when we start it, it runs the main loop or the main event loop. We're going to need to include this as a line in our tkinter code. And as I stated earlier, the app form just opens. The parent topmost form opens and just sits there and waits for user input. Before we get into completing this nugget with a practical demonstration of using tkinter, I want to give you a heads up for those of you who are into integrated development environments, especially for graphical applications. You should know about Visual tkinter. This is a GUI builder for Python 2.6, and just from the looks of it, those of you who are familiar with the Microsoft Visual Studio applications should immediately feel at home in terms of you have your graphical drag and drop form designer, your toolbox, you can set properties over here on the right, and even build your application in Windows using the Py2Exe tool. So this Visual tkinter will hide or abstract a lot of the coding and heavy lifting that you would have to do normally. I'll tell you, the reason why I like this tool so much is I'm never a fan of manually specifying form geometry. I would much rather just, instead of specifying X and Y coordinates, column numbers, and row numbers when I bind controls to a form, I like to just drag and drop and align them that way. Much easier. Now, enough with me talking, let's get to the demo. To start this demonstration, I want to turn you on to a really nifty application, not written in Python, unfortunately. This uses the Adobe Air runtime, so it was built in Adobe Flex. This is called Balsamiq Mockups for desktop. Because it's Adobe Air, it'll be completely cross-platform. I'm running it on Windows, of course. And mockups, I feel, in my professional life, I share this with you, are really important for visualizing graphical user interfaces. Balsamiq Mockups makes it really easy to mock up not just desktop applications, but you can mock up web browser or web application interfaces just as easy. There's this huge library of all these different controls, common controls, button controls, layout, markup, media, etc. And just with a few drag and drop actions, I've created this simple wireframe here called feet to meters. This is going to be the example application we're going to build in just a moment that I adapted from tkdocs.com. Alright, so that having been said, preliminarily I also wanted to turn you on to some good reference references for learning TK-Enter. Believe it or not, TK-Enter doesn't have any official documentation. Therefore, quite honestly, a lot of folks just go to Google and type TK-Enter documentation, and it's kind of a crapshoot what you're getting back. I do want you to be aware of some resources that I think are especially helpful. Now, not only is this book by Manning, Python and TK-Enter Programming, one of the only, if not the only, title on the subject on the market, I've gotten a lot of mileage out of reading these Manning books. They have another fantastic volume called the Quick Python Book. New Mexico Tech, nmt.edu, has a document called TK-Enter 8.4 Reference, a GUI for Python. As you see, this is a 118-page document. The date stamp on here says 3/27/2010, which, as of this recording, is super current. And it's essentially an online book, free for reading, that covers TK-Enter in a pretty good degree of depth from start to finish. Finally, a pretty standard place to go to get TK-Enter documentation is pythonware.com/library. They have an introduction to TK-Enter. There's a much older book. This is 1999, so it's still pretty old. You can look for Thinking in TK-Enter as well. Frankly, I would suggest that if you have some aptitude for this and some literary ability, write your own online guide and share it with the community. Our first example is an extraordinarily simple graphical user interface, but that's just fine because we just want to give a look and feel for how TK-Enter works. From within idle, I'm going to run this module, and we'll just take a look at it first. This is a simple application, one parent window, that's all. The title text is Button App. We have one label control that says I am a button. We can minimize, maximize, close. We can resize. I'm just leaving all the behaviors at the default. You'll notice that as we resize the window, the button and the label remain centered on the form, and then if we click quit, it quits. So I've wired that up appropriately. Now let's come back and look at the source code. The first thing we're going to want to do is make all of our classes available from the TK-Enter module. Now, generally speaking, you'd want to use the from import syntax here so you don't have to keep retyping TK-Enter dot, TK-Enter dot. You remember, if we use from TK-Enter import, we're going to bring all of the TK-Enter names into the current namespace. Now, we run a little risk of name collision there, but as long as we're creative with our names, we should be just fine. Next thing we want to do is create the root or parent window. This can have any name, but general convention is to call it root. And what we're doing here, you know from object-oriented programming, is that we're instantiating an instance of the TK class. This is going to give us our base form. We can then begin accessing built-in methods and attributes of that class to begin to decorate or mark up that object. For instance, root.title enables us to pass in a string that gives us the window title. Next, we're defining a label control, and the way named attributes work is similar to how, if you've used XHTML, those named attributes work. In other words, we have the label, which is going to transparently instantiate an instance of that class, and then in parentheses we can add a comma-separated list of named attributes. Here, I'm just giving one, text equals, but you can also do a whole lot more. Like, for instance, down here, when we instantiate the button on the form, we're providing